TA. This is the channel whereby we teach you mathematics, chemistry, and physics, and we always make it simple. Now, guys, if you haven't subscribed to my channel, please do so. Please also like and click the notification button. All right, today I'm going to be teaching you guys a very interesting topic in maths. I'm going to be teaching you guys a very interesting topic, calculus. Very interesting topic, calculus. This topic also touches functions. And as I have already taught you guys, when we are solving functions, we try to solve for the roots or the x-intercepts and the y-intercepts, as well as turning points. However, we will also solve the point of inflation because we're going to have cubic functions as well. So let us start with this interesting topic, calculus. All right. With calculus, I'm going to draw a function which is very common. Everyone knows what a parabola is. If you don't know it, yeah, you can comment on the comment section. Guys, if you have any question, don't hesitate. You can put it in the comment section. I will attend to it. All right. Let's say if you have a function, and that function has a certain gradient. But as you can see, all the gradients differ from point to point. So in this segment, we are going to find general equations that we can use to define the slope at any point on this function. And also note that the slope is actually the slope that is perpendicular to the curve, perpendicular to the normal of the curve. Now, this is the normal. This is the normal of the curve. So this is the gradient that we are talking about. The normal of the curve at this point. This is the normal, and then that's your slope. All right. Now, if we have a situation like this one, whereby we have 2 points, the first point, let's say for instance, is x by f of x. Now, this is the functional value. Then to move from that point to that other point, let's say if we are moving, let's say if this movement is the movement h, from this point to this point is h, then what will be the distance from this point to that one? That distance there will be f of x plus h. I think we all agree on that one. That means this point here will be x plus h, because from here to here is x, and from this point to that one is h plus x. I hope that makes sense. But if it doesn't make sense to you, please don't hesitate. Go to the comment section and comment. Now, the slope of the slope from this point to that point will be given by the average gradient. It will be given by y2 minus y1 over x2 minus x1. This is very simple, isn't it? Now, using our function, let's assume this is 0.2 and this is 0.1. This will mean that we have f of x plus h minus f of x, which I hope most of us agree with that, over x plus h minus x. And this will be f of x plus h minus f of x over x minus x. They will all cancel out if we all agree with me. This is what we are left with. Now, this is the fundamental equation. If you want to find the slope of the graph using the fundamentals, you use this equation. Fundamental principle. All right. Now, how do we solve the slope or the derivative using mathematical rules? So using the rules, so we have the derivative of x to the power of n with respect to x. Note what I just said, with respect. All right. The rule says you take whatever that is on the exponents, you multiply it with the remaining part of the formula. However, you minus 1 all the time. That is the rule. And it ends there. Now, one of the rules that is also very important is that the derivative of the sum of two functions can also be written as the derivative of two separate functions with respect to x. All right. That's G, sorry. All right. I hope that helps. Now we are going to examples. The first example that I'm gonna give, let's say for instance, if we have f of x equals 2x to the power of 3 plus 3x minus 1. Now, if we apply the first rule, if that's the equation, now the derivative, which has that little symbol there, will be 3. We bring down 3, and then we multiply it with the original the original expression to the power of 3. That's what it was. But we subtract 1 plus 3 plus the exponent here is actually 1. It's actually 1 times 3 to the power x. 1 times 3 x to the power of 1 minus 1. Then minus, now the derivative of a constant is 0, always. Now, what we're going to be left with is actually 6x to the power of 2 plus 3 plus 3. It ends there. Now, that equation, it is the slope equation of the function f of x. All right. Now, we need to draw we need to also draw the graph, but I'm not gonna draw the graph now. I'm gonna give you guys another example. I'm gonna give you guys another example. Another example will be, let's say, for instance, f of x. If it's given by x to the power of 3 minus x squared minus 5x minus 3. So we want to draw the function. All right. Now, in order to draw the function, we need to determine or to determine the roots or the x-intercepts where your graph cuts x-intercepts. All right. Now, to find the x-intercepts, we're gonna use, because it's a cubic function, we're gonna do trial and error. Let's say, for instance, at the x-intercepts, this is where y equals 0, or this is where your f of x equals 0. So we're gonna try. Now we're gonna test x equals 1. We're also gonna try x equals minus 1. You can try as many as you can. And sometimes you can actually see using your naked eye, you know, those that are very quick and those that that have scanning eyes. So let's try to substitute. Let's see if this equation, if we replace by 1, if we replace by 1 squared minus f into 1 minus 3. Let's see what this equals to. This will be 1 minus 1 minus 1, so it will be 0 minus 5, it will be minus 5, and minus 5 minus 3, it will be minus 8. Therefore, these are not equal. Right. Let us try x equals minus 1. We can try as many as we can. We can even try x equals 0. Now, let's try x. With x equals 0, we're gonna have 0 equals 0 to the power of 3 minus 0 to the power of 2 minus 5 into 0 minus 3. And 0 can be equals to minus 3. It can be. All right. Let's try x equals minus 1 and see what we're gonna get. Who knows? Maybe this will work out. We're gonna have minus 1 to the power of 3 plus, no, it's not a plus, sorry guys. All right, we're gonna have minus 1 squared minus 5 into minus 1 minus 3. Let's see. This will be minus 1. So it will be minus 1 plus minus 1 minus 1. This will be a plus. Negative times negative, this will be a plus 5 minus 3. Now, minus 1 minus 1 minus 2. Then minus 2 plus 5, it will be plus 3. Plus 3 minus 3 is equal to 0. Yay! We already have a set of roots, which is x equals minus 1. Therefore, x, if we take minus 1 to the other side, x plus 1 equals 0. Therefore, x plus 1 is a factor. All right, we already have the root. Now, we want to solve for the remaining solutions, or for the remaining roots. As we know, we have x plus 1 as the root, as one of the root. We're gonna use a long division method to calculate the other roots. All right. Now, what we're gonna start with, we're gonna start by dividing x to the power of 3 divided by x, which is x to the power of 2. Now, x to the power of 2 times x, it will give us x to the power of 3, then x squared times 1, it will be plus x squared. Now, if we subtract these two terms, we're gonna be left with, so it will be minus x squared minus x squared. It will be minus 2x squared. I hope you agree with me. Now, we're going to bring one term. We're going to bring the following term down so that it can battle with this term. All right, now let's see. Let's divide again and see. Now, minus 2x squared divided by x, it will give us minus 2x. We're going to do the same thing again. 2x times x, it will be minus 2x squared. 2x times 1, it will be minus 2x. Again, let us subtract. This will be 0. Minus 5x minus 2. It will give us minus 3x. Again, we're going to bring the following term down, which is 3. All right. Now, minus 3x divided by x. Once again, this will be minus 3. Now, minus 3 times x, it will be a minus 3x. Now, minus 3 times 1 will give us minus 3. 3x minus 3x, 0. Minus 3 minus 3, again 0. For the remainder is 0. Therefore, we have solved for another equation that will give us the roots. We will have x plus 1 into, let's look at this equation. It will be x squared minus 2x minus 3. X squared minus 2x minus 3. All right. Now we need to solve this quadratic equation as well to find where the roots are. And let's see. Now, already we know that x equals minus 1. With that equation, we can factorize, but I prefer not to factorize because factorizing can be a little bit harder. I always use the quadratic equation to find the roots of a cubic equation, or of a cubic factor, sorry. Now, your x is given by minus b, which is minus, your b is minus 2. B will be minus b, your b is minus 2, plus or minus the square root of b squared, which is minus 2 squared, minus 4ac. Now your a is 1, and then your c is a minus 3, all over 2a. Now 2a, it will be 2 into 1. I hope you all agree with me on that one. This is equals to 2 plus or minus the square root of, let's see what we get now. This is 4 negative times negative, it will be positive. Now it will be 4 plus 12, because 4 times 3 is 12. Now 4 plus 12 all over 2. This will be it will be 2 plus or minus the square root of 16 over 2 is given by the square root of 16 is 4. So it will be 2 plus or minus 4 all over 2. So these are the two roots that we have. We have a plus and a minus root. So x will be 2 plus 4 divided by 2, which is 6 divided by 2. It is 3, or 2 minus 4, which is 2 divided by 2. And it gave us, let's see. It gave us x equals minus 1, because that's going to be 2 minus 4, which is minus 2 divided by 2. That's a minus 1. Now, these are other factors. If you take 3 to the other side, it will be a minus 3. If you take minus 1 to the other side, it will be x minus, it will be x plus 1, sorry. So these are all the factors that we have. X plus 1. This is your f of x, which can also be written as x plus 1 squared x minus 3. All right. We already have the roots or the solutions. Now, what is the turning point? If you take the equation and you find the derivative of the function x to the power of 3, x to the power of 3 minus x to the power of 3 minus x squared minus 5x minus 3. Now, the derivative of that equation will be 3 times x to the power 3 minus 1 minus 2 times x to the power of 2 minus 1 and minus 5 minus 1 times 5x to the power of 1 minus 1. The derivative of the constant is 0, always. Now we're going to have 3x squared minus 2x minus 5. Now, this is the derivative equation. And what we know is that where the slope is 0, this is where we get the turning points. All right, now your turning points will be, let's see, 3x squared minus 2x minus 5. Now, again, this is a quadratic equation. Now your x is given by minus b squared plus or minus the square root, minus b plus or minus the square root of b squared, which is minus 2, minus 2 squared minus 4ac. Now your a is 3, your c is a minus 5. Now let's see what we have over 2a, which is 2 times 3. All right. Now we're gonna have 2 plus or minus the square root of 4. 4 times 3 is 12. And 12 times 5, let me get the calculator. Let me get the calculator. Let me get the calculator. Excuse me for a few seconds. All right. 4 times 3 times 5. 60. Negative times negative, positive. Now over 6. This will be 2 plus or minus the square root of 64. Now the square root of 64 is 8. 8 over 6. Eight over 6. Now, our roots will be, now your x is given by that. Now, our roots will be x equals, let's see, 2 plus 8 is 10. 10 divided by 6, you will agree with me, it will be 5 over 3. Or 2 minus 8, it will be minus 6. Minus 6 divided by 6. Your x will be minus 1. Now, these are the roots. The roots are when x equals 5 over 3, or when x is minus 1. We appear to have two roots. We appear to have two roots in this equation, but let us evaluate further. We appear to have two roots, which is 5. So we have two turning points. Two turning points, then that's good. Now, the point of inflation. The derivative function is given by 3x squared minus 2x, 3x squared minus 2x minus 5. Now, in order to find the point of inflation, we need to find the third derivative, which is the derivative of the derivative function. We're going to have the following. We're going to have 2 times 3x to the power of 2 minus 1 times 2x to the power of 1 minus 1 minus 0. This will be 6x minus 2. Now, at the point of inflation, this is where the third derivative is 0. Therefore, when 0 equals 6x minus 2, we have x equals, if you take 2 to the other side, to be 2 divided by 6, which is 1 over 3. All right. Now, what is the y-intercept? This is where x is given by 0. If you go to the original function, your y-intercept will be minus 3. So it will be y equals minus 3. Now that's a y-intercept. Now let's see how the function will look like. First of all, we know that this is a cubic function. That's number one. Now, number two, we know that the cubic function has an inflection point, which we have already solved. Now, let us mark the important points first. Point number one, let us look at the solutions. The solutions we have, your function cutting at a point x equals 3 and x equals minus 1 twice. That's what we know. All right. Let's say minus 1 is there. Say minus 1 is there, minus 1. Then your 3 will be there. If your function is cutting twice, means the curve will cut at that point. All right. Now, to draw the function, what are other critical points? The other critical point that we have are the turning points. Now, the turning points are at minus 1 and 5 over 3. 5 over 3 is actually 1.3333. So this is it. This is where the other turning point is. Now, I want to test curvature. I want to see if the curve is like that or it's like that at that point. Now, I'm going to go to the derivative function. The derivative function and try to replace with a value. Let's say your derivative function was 3x squared minus 2x minus 5. All right. Let's say let's try to check at a point minus 2. Minus 2, this will be 3 into minus 2 squared minus 2 into minus 2 minus 5. I just want to see if the slope is positive or not. This will be 3 times 4, which is 12, minus minus 2 minus 2. This will be plus 4. And then minus 5. Now, 12 plus 4, this will be 16. Now, 16 minus 5, it's 11. So, this is how it will be. Now, the curve will be positive because this is the minus slope. So, I nearly made a very big mistake. So, your curve will be like that. And then if it's like that, now we also have a y-intercept, which is minus 3. So this graph will cut at minus 3. Now the other curvature is here at 5/3. So we know that the graph will cut at minus 3, then 10, then go back and cut the x at that point. This is what we have. And these are the solutions, the two solutions, 3 and minus 1. Now, the two turning points were, let's see, two turning points were 5/3 or minus 1, which I've already done. Okay, and then the point of inflation, the point of inflation the point of inflation, the point of inflation, the graph will look like that. So they're saying the point of inflation will be somewhere there. That's where the point of inflation will be. All right, guys, that's how your function f of x looks like. Thank you so much for watching this lecture. Please don't forget to subscribe, like, and click the notification button for more content and for more lessons. I will see you on the next one. Thank you.